I'm going to go through some of the main facts and figures from the latest inventory in this presentation and focus in on the key drivers. But I'd encourage everyone to have a look at the report, and we'll have a question and answer session afterwards where we can pick up on questions you might have. First of all, where does this report fit in? Well, this report is produced to meet EU and UN requirements for greenhouse gas inventories, and those requirements are met next March and April when we do the final submissions to the EU and UN respectively. So this is the first site for national users, and isn't the full version of the inventory. So the land use change and forestry part is not yet complete, and that will be in the final version next March. So just to be clear, this covers is a provisional view, and it covers the vast bulk of the emissions, but is not the final version yet at this point. So in the presentation, I'm going to start with some of the highlights and the overall trends. I'll move into then the sectoral drivers, and then finish up with a bit on the compliance and future targets. The EPA's Office of Environmental Sustainability and the wider EPA have quite a substantial number of roles in relation to climate science. This is the output from the inventories and projections team, but we also take input from various other parts of the EPA, such as the Office of Environmental Enforcement with the emissions trading information, and we take input from research in various other areas. And also there is a substantial broad range of responsibilities in the EPA, including the climate dialogue and servicing the climate council with the climate secretariat. The data that we produce isn't all produced by the EPA either, so we're a data taker in the inventory world. We take data from the SEI, from CHAGISC, and from various other departments, agencies, and also the commercial sector and international agencies. As Emer just described at the beginning, we've got a welcome reduction this year in the overall greenhouse gas emissions. 2019 estimates show that we've seen a decline of 4.5% on 2018 levels, down to just under 60 million tonnes of carbon dioxide equivalent. And most of that has been driven by less coal being used for electricity generation. So almost 70% less coal was used in electricity generation in 2019 compared to 2018. The other sector that saw a big decrease, as Emer pointed out, was agriculture, where we saw less fertilizer and lime being used, and that reduced the agriculture emissions. Those reductions will be difficult to sustain in the agriculture, however, because the underlying drivers are continuing to increase, such as dairy cow numbers. So just to spell it out in the numbers in a little bit more detail, what these numbers are saying is that the Ireland will exceed its 2019 annual limit under the effort sharing decision by just under 7 million tonnes, and that follows having exceeded for the previous 3 years as well. So as of the end of 2019, we're estimating that with the provisional numbers, that the cumulative shortfall for the period 2013 to 2019 is about 5.4 million tonnes, which makes it extremely unlikely that 2020 emissions, even with the COVID impact, could allow us to meet the target for the overall scheme over the period 2013 to 2020. The energy industry's emissions showed a decrease of 11.2%, over a million tonnes in 2019. And I say that's driven by coal and peat reductions. The agriculture emissions reduced by almost 4%. And again, that's the substantial reductions in fertilizer and lime. The greenhouse gas emissions from the residential sector decreased by over 7%, again, about 500,000 tonnes. And coal use being down and peat being down were big factors there. And transport emissions only decreased marginally, as Emer pointed out. Although there was a substantial increase in biofuel, the increased demand largely cancelled that out. So there's the key sectoral highlights. You can see that most sectors are reducing, as well as the ones I've mentioned already. We've seen reductions in F-gases in manufacturing, combustion, industrial processes, and the commercial public services going marginally the other direction. What this means from the for the annual trends is that we've seen a 2.8 million tonne decrease in 2019, and on the scale that compares with the big reductions we saw coming out of the recession. So in 2009 and 2011, they're the only years where we've seen a reduction larger than that in the last 30 years. The sectoral contribution to those emissions, it's 35% agriculture, followed by transport at 20% and energy at 16%. And after that, then residential, manufacturing, combustion, etc. So it is the same big three sectors. But if we look at how it's evolved over time since 1990, we can see that transport in particular has jumped up from being 9.5%, where it was the fourth highest sector at the time, to now being the second highest at 20%. Energy has declined in relative terms from over 20% down to 16%, and residential emissions have also declined as a proportion. Agriculture declined for a period and then rebounded, so it is more or less the same proportion of overall emissions now as it was in 1990. So just focusing in then on these sectors one by one. Let's say in agriculture, we see a decrease in fertilizer, 10%, lime of 25%, but dairy cow numbers underlying that are up 2.8%. If you look at the trend, we can see that for the last, for 7 of the last 8 years, we've seen increases in agriculture emissions. So we have a 0.9%, a 3.9% decrease this year. We had seen increases from 2014 to 2018. And this is largely caused by the increases in the dairy herd since the ending of the quotas. So if we look at the drivers behind that, then the dairy cow numbers, we can see that the Republic is producing about 8.3 billion litres of milk in 2019, which is about a 60% increase on pre-quota levels, which are around 5 billion litres annually. So the exports in 2018 were valued at over 4 billion. So this is the agriculture emissions. Although we've seen a decline in fertilizer and lime, we have to factor in that in 2018 there was drought conditions, and that resulted in a lot of fertilizer and lime being added to try and grow grass, and it also meant that a lot of concentrate feed was being fed to animals because the grass was not available. So what we're expecting, given that 2018 was the highest point in the series and in the 30-year series, is that those numbers are not, that those reductions in fertilizer and lime are unlikely to be sustainable, and that we will see a increase again as the underlying drivers take hold. Road transport emissions, you can see there's the increase from 1990 on the very left there, 142% higher in 2019 compared to 1990. The peak year was in 2007, where we had over 14 million tonnes of CO2 equivalent, and it's declined somewhat since then, particularly during the recession. But 5 years after 5 years of decreases from 2007 to 2012, we now see 5 of the last 7 years the emissions have increased. What we are seeing in the last 2 or 3 years here is that the transport emissions being relatively flat, and this is as a result of the increase in biofuel, mainly offsetting the continued increase in demand. Road transport, as you can see from that, is the vast majority. It accounts for 95.3% of emissions overall. In fuel terms and energy from fuel terms, you can see the energy consumption from diesel, petrol, and biofuel, and you can see the diesel has increased in recent years, but petrol has decreased, and biofuel at the bottom, whilst at a very low level, is gradually increasing. So that in 2019, it accounts for about 4.5% saving on CO2 emissions in the transport sector. I'm putting in a short piece on international aviation. Although international aviation is not included in our total national emissions, we reported to the EU and the UN as a memo item, which means that it's not counted part of the total, but it's reported for information purposes. And the reason for that is that the International Civil Aviation Organization, an agency of the UN, has responsibility for coordinating reductions in aviation emissions globally. So it's to be managed at a global level, and that's not included in individual countries' inventories. But it's important because it has been increasing in recent years, to focus a little bit on the scale of aviation emissions. And if you look at the graph on the right there, you can see that if international aviation emissions were included, as part of our transport emissions, they would account for about 20% of total transport, with private cars almost half. So in 2020, global international aviation emissions are around 70% higher globally than in 2005, and the ICAO has forecast, and this is obviously pre-COVID, that they could reach 300% of 2005 levels by 2050. So it's an increasing source of emissions, 2020 notwithstanding with the COVID impact, and it is likely to be something that will need to be tackled urgently over the next number of years. And we're aware, obviously, at the EU level of discussions around tackling it at a European level. Moving on to energy then. So this is where we're seeing a really positive story, as Emer highlighted at the start. And it's largely been driven, if we can see, there's been a gradual reduction from the peak in 2001, and it's been driven by increases in renewable share, and also scaling down of the less efficient fuels such as coal and peat over that time. And particularly in the last 2 to 3 years, we've seen big reductions. And we've seen a 25% reduction in emissions from 2016 to 2019. And a big part of that is the phasing out of coal and Money Point in particular, with peat also declining as a share of overall energy production. But renewables are also significant. In 2019, renewable share was up to 38%, up from 33% in 2018. And that does vary from year to year depending on wind levels, but also has been driven by increased capacity being added all the time. So this is very positive and heading in the right direction, and will also help other sectors decarbonise, obviously, as electric vehicles to take on more in the transport sector, and heat pumps in the residential sector, for example. Just to look at what that means for the energy production, you can see that there's been a really impressive decline in the CO2 intensity of electricity generation, albeit over 30 years, from almost 900 grams per kilowatt hour of electricity generated down to just over 300 in 2019, which again is a record low, and we're seeing record lows nearly every year, give or take a certain amount of variability due to wind levels. But the renewable generation on the system and the reduction in coal and peat are the key drivers behind this improvement. Residential emissions then, again, we saw a substantial decline, as highlighted by Emer in 2019, but it is also a decline that's driven by weather more so than a huge impact from underlying efficiency gains. Having said that, coal use reduced by 29%, and peat use also declined substantially. So we have seen, in fact, between 1990 and 2019, a reduction of over 70% in solid fuel being used for residential heating. So this is a very positive fuel shift away from more energy intensive fuels to more efficient fuels. But what we have seen in the more recent years in particular is somewhat of a stagnation of that improvement. So if we look at the emissions per household, we can see that from 2014 onwards, really, the level has been, give or take, some variability due to weather, the level has been fairly constant. And this is slightly worrying, I suppose, given the ambitious targets we have for emissions reduction, that we need to see that kind of downward trend that we saw from 1990 to 2014 brought forward, and which will require a step up of residential retrofit measures to achieve. Just a little bit on the weather side of things. So the black line here, this is what we call the degree day count for Met Éireann, and a degree day is a measure of how far the weather is from a baseline where no heating or cooling is required, which is given as 15.5 degrees. So the more of these days you have, then the more the heating requirement is. So if you look at the black line there being the average and the red line being 2018, you can see a big, in this beginning of the year from January to March, far fewer degree days in 2019 in what would be the peak part of the heating season. So that would largely explain the reduction we would have seen in residential emissions, albeit there's also an impact from the fuel switching away from coal and peat. The residential sectors, the remaining sectors, I mean, the report also covers commercial, public service, manufacturing, combustion, industrial processes, waste sector, and F-gases. And as I say, some of these sectors are not in this yet, such as the land use change, and forestry sector. For commercial and public services sectors, emissions increased by 1.8 and 1.2% respectively, driven by increase in natural gas use in those sectors. In the manufacturing combustion sector, we saw a decrease of about 2%. Industrial processes, a decrease of about 1.5%, which was due to cement production reductions. The manufacturing combustion was also partially cement production, but also the food and drink sector. For waste sector, we saw emissions decrease by 0.8%, and this really follows a long-term decrease resulting from decreased quantities of municipal solid waste being landfilled and reduced methane emissions from landfills as a consequence, as well as the diversion away from landfills to incineration in particular. F-gas emissions are substantially down from 2018 to 2019, and having been down substantially the previous year as well. And these reductions are to do with reduced global warming potential refrigerants, lower global warming potential refrigerants being used, particularly in refrigeration and for mobile air conditioning in cars. And that's been a decline that we've seen over the last number of years. However, over the longer term, F-gas emissions did increase substantially in the late 90s and early 2000s before this decrease has begun to take hold. Focusing a little bit on compliance with our EU targets. So we have a target under the effort sharing decision, which is defined as 20% below 2005 levels. But the way that's actually being brought into the actual numbers is a cumulative target, annual targets, I mean, which are represented there by that green line. So they're the annual targets, and if we exceed a target in a given year, we can we generate an exceedance, which can be offset by surpluses achieved in other years. So as you can see from that graph, we had surpluses in 2013, 14, and 15. But since 2016, we've been exceeding our target. I should just highlight, the blue bar is the effort sharing decision emissions. The red bar on top is just for reference. That is the emissions trading scheme emissions, which are not governed by the effort sharing decision, but governed at a European level under the emissions trading scheme. So we saw an exceedance of, as I mentioned at the start, of almost 7 million tonnes in 2019, compared to the 38.7 million tonne effort sharing decision target for the year. And what that means when we combine all of those numbers together is that we have an exceedance, a cumulative exceedance of approximately 5.4 million tonnes to date, to the end of 2019. And what that would mean would be, given that the target goes down again for, it's a linear reduction pathway, given the target goes down again for 2020, we would be expecting to see a reduction. We'd need to see a reduction in effort sharing decision emissions in 2020, well over 25%, to be in the ballpark to cumulatively comply with the effort sharing decision target. So that is extremely unlikely to happen based on what we know from 2020 emissions so far from monthly data, and so essentially it's impossible to meet this purely with the numbers themselves. So there are obviously other compliance mechanisms in relation to use of fees of credits and purchasing annual emission allowances from other member states. And just then to compare where we sit in comparison to other EU countries, we can see here Ireland is the fourth highest in terms of per capita emissions. Now these are 2018 numbers, 2019 numbers are not available yet for Europe, but we won't be far off this position in 2019 either. And you can see the breakdown there between of the overall per capita emissions of just over 12 tonnes per person, and that about 8 tonnes of that is methane, is CO2, about 3 tonnes of that is methane, 1.5 tonnes N2O and 0.24 other F gases. And you can see there that methane is obviously a more significant part of the mix for Ireland than it is for a lot of other countries, which reflects the importance of agriculture in our economy. But even notwithstanding that, the CO2 emissions, the blue bar, would still place us in the upper half of that list on their own. So in conclusion then, we've a really welcome decrease, and I think it's important to point that out. What we've been calling for some time, to see the exit of fossil fuels in power generation, in particular energy or emissions intensive fossil fuels such as coal and peat. So that's a really welcome decrease. However, I mean, in terms of the 2020 targets, we're still not on the pathway for those. And it remains to be seen in terms of the increased ambition for that would be expected under the programme for government and from the new EU targets that are being worked on at the moment. We will need a step up in ambition, and in particular the measures in the climate action plan will need to be at a minimum those implemented in full in order to get us on target for 2030 and longer term, and for the ambition nationally for a climate neutral economy. We're expecting to see reductions in 2020 emissions as a result of the pandemic, but as I said earlier, this is highly unlikely to help us comply overall with the EU emissions effort sharing decision targets, and it also does not negate the need for long-term sustained action, because once we come out of that COVID pandemic, if the underlying situation has not changed and the direction of the economy has not changed and fuel prices are quite low at the moment, there is a possibility that emissions could rebound substantially. So it's important that we focus on climate action as part of a green recovery out of the pandemic, which offers us this opportunity to respond to climate change whilst rebuilding the economy and do those two things together, creating the win-wins and generating new jobs. So finally then, if you want to get any more information on what I've just presented, we have updated our website this morning, so everything in here is now on the website at www.epa.ie/GHG.